So my name is Ben Adler. I'm the CTO of the Phoenix LiDAR Systems. This is the third time, I think, that we're here at InterGEO. We started in Stuttgart in 2015. And the presentation is titled An Introduction to the New Phoenix LiDAR Systems Post-Processing Tools. We just did a live demo outside with one of our new LiDAR systems on an M600 scanning the Sommergarten. So it's a bit of a hodgepodge because it literally just arrived because of the bad weather. This presentation is pretty much about what happened at Phoenix LiDAR Systems the last year, and we did have a strong focus on post-processing. And the reason is that we have a wide variety of customers. We have large corporations that have their own post-processing departments. We have medium and large surveying companies, but we also have small customers, going down to just the pilot and the business guy. And we saw a trend that the smaller the company, the more likely they are going to struggle with LiDAR post-processing. As opposed to photogrammetry, LiDAR post-processing is a slightly more involved process, just because of the dynamics of the solution involved. There is a bit of expertise required, so especially if you're not from a geodetic background, you don't necessarily understand the datums, projections, and whatnot. So that adds a bit of a learning curve. It also adds high upfront software costs. So open source tools can carry you a bit of the way, but if you want to deliver accurate results repeatedly, you're usually looking at software costs of $2,000 to $50,000 upfront. And of course that is a very high price tag, especially if you just bought a LiDAR system. Also usually, or in classic post-processing scenarios, this software runs either on a local workstation or on a local network. So you're bound to your local workplace. To extend the current offering and offer an affordable and easy entry into LiDAR post-processing, we constructed LiDAR Mill. LiDAR Mill is an interactive website that allows you to subscribe for an affordable price and upload your LiDAR data. And LiDAR Mill accepts any subset of LiDAR survey data. So you can start with just the reference station and the rover's IMU and GNSS data to compute a trajectory, or you can also add your actual raw LiDAR data and camera data. And LiDAR Mill will automatically process right now we're at 80% of data sets that we can process. There's always going to be the corner cases and the difficult data sets, the bad weather, the GPS obstruction, and the pilot didn't fly right. So there's always going to be those cases that we can't automatically process. But the goal is to get to a 90% of data. LiDAR Mill does provide comprehensive quality reporting, which is an essential part of LiDAR post-processing. There's QA and QC every part of the step. A, to prove your results to the customer, and B, if something does go wrong, you want to know where that was. In the nature of a website is kind of built-in collaboration and sharing, just because you can access it from everywhere. We also offer expert support at quite discounted rates, just in case you are having trouble with your LiDAR data set. So as it's a website, you better be online. That's one thing I forgot. All right. But while we're getting online, I'll show you, this is an example of trajectory post-processing. So what we did is we uploaded the reference station data, and LiDAR Mill can automatically solve your reference station position through either local services like Opus or PPP or other services. Once that's done, we do trajectory post-processing, and this is an example of a result. So what happens is we process the trajectory from beginning to end. So we walk through the reference station and rover GNSS and IMU data, build a forward trajectory and then recompute the trajectory in a reverse solution from the beginning to end. The idea is to remove, basically to run a second statistically independent computation and then smooth out the errors or the disagreements between those two forward and reverse trajectories. And this graph shows just that, the disagreement in position over about 1,000 seconds, so this was like a 20-minute flight. And we can see that the forward and reverse trajectories agree down to better than a centimeter. So right here we are at, in perfect agreement, so down to the millimeter. The same is available for the orientation of the vehicle, which is important because the LiDAR point cloud is, in the first processing steps, directly derived from the vehicle position and orientation. So it's just geometry. So if you have an error in your angle or heading computation, that gets directly reflected in the point cloud before you do flight line matching. So here we can see that usually pitch and roll are perfect, and the separation in yaw is better than 0.01 degrees. So that's a happy trajectory. Yeah, so this is a classic project. What happens is that you start uploading your data. In this case, it was a reference station, rover navigation file, camera files, and LiDAR data, and that gets processed using pipelines into trajectory and point cloud. This is an example of a point cloud that we generated. This was a Ranger system flown over Los Angeles at, I think, 60 meters height, and you can clearly see if 4G works. Yes, you can see beautiful colorization, power lines. I think there should also be classification. Yeah, here you can see power lines and ground and non-ground separated. That part of LiDAR Mill is still in beta. So we're currently still working on LiDAR Mill. We're doing a public beta now. We have been evaluating this with our existing customers over the last few months and gotten some quite positive feedback. So we're now trying to extend the range of testers. Yeah, we're hoping to extend that a lot during the next year and offer more and more comprehensive post-processing that's automated. Now I'm going over to the hardware side. So last year saw the introduction of the miniRANGER, and now of course also the miniRANGER DL, so the downward-looking version. The miniRANGER in general is just a downscaled and miniaturized version of the Ranger with a lot of the benefits of the Ranger, which includes a great range. So of course depending on reflectivity, but you can expect a good 150 meters against dark targets and 250 or more against brighter targets. And what that means is that you can comfortably fly at 100 meters AGL, and the camera footprint matches the LiDAR footprint pretty well. So if you're using a Velodyne system, your range is, depending on if it's the Park or the HDL32, you're actually flying 25 to 60 meters above ground. And if you want to capture LiDAR and photogrammetry at the same time, it's a bit of a tough endeavor to make the camera footprints fit the LiDAR footprint. So either you use a wide angle lens, or you fly twice at different heights, or you have pretty narrow scan lines. So that's pretty good. We also get up to 5 returns, really 3 that are really usable, and 4 and 5 then fall off, which means you can penetrate vegetation quite well. Of course, it doesn't get you quite as far as the Ranger, because this still is a 905 nanometer laser, so it's not quite as powerful, but it does get you to the ground quite well. Of course, we offer upgrades to that LiDAR for all of our existing units in the field. The real game changer, though, is the TerraHawk CW-30, and for us, this means that we're finally past the flight time and area limitation. So this is a large UAV, but it has it's a hybrid UAV, so it can do vertical takeoff and requires absolutely no infrastructure, so no runway, and so it's very user-friendly, and yeah, you're not limited to airports or flatlands. This thing actually flies a good 2 hours, and it's perfectly reasonable to expect up to 50 square kilometers of dense LiDAR per one flight. It is also capable of capturing both ortho imagery, or imagery and LiDAR at the same time, just because it can carry that kind of payload. And most importantly, it is user-friendly. We are cooperating with Joe UAV, who are just next to our booth, and they are producing those in the numbers. And we have seen this vehicle start and land and start and land many, many times, and are quite confident in its performance. This is just a summary of the software updates we did. We're pretty customer driven in what we do. So sure, we provide our set of software, but we get lots of feedback from customers all over the world. And the first thing they asked us for was a flight planning tool, because it can be hard to figure out, I need this kind of LiDAR swath, I have this lens, this camera, this LiDAR scanner, I trust it to give me points up to this range for this application. And it's very helpful to have a tool where you just set your parameters, your required GSD. If you do ortho, your required points per square meter, how far you want to go off nadir in the LiDAR angle, and it spits out the altitude, forward velocity, and flight line spacing. And of course you can vary in all of those, because what we always find is it's nice to plan your mission before you get to the customer, but once you meet the customer, you really only understand what he wants scanned. And it's rare that a flight plan actually survives meeting the customer. We do create terrain following waypoints, which can be imported in some flight controllers. So that was a request. We optimized fast and real-time RGB. So we do project colors like this screenshot shows. We do project colors into the point cloud as we fly. We also, of course, do that after landing with the full density point cloud. Oftentimes customers are very interested in using the photogrammetry part of our system, so georeferenced image capture. Once that works, they're very interested to see that we can directly project the images into the point cloud, which is not accurate to the centimeter like photogrammetry can be, but many people then find out, well, I do have the colors in the point cloud just for orientation, whereas the actual accuracy is derived from LiDAR. So it's actually a pretty good fit and saves you hours and hours of photogrammetry post-processing. So the processing is about real time. So if you fly an hour, you have a colorized glass file in an hour. Of course, we also stream the colorized glass file. We integrated hyperspectral and the Ladybug 5 Plus camera. The hyperspectral is mostly a research topic. There's also customers in defense and ag industries, but that's usually very, very specialized. We added features like flight line auto splitting, so oftentimes if you have an autopilot that does the flight lines for you, it's quite easy to derive those and cut out the curves. So we're just trying to optimize and take steps out of the processing pipeline. We were asked for a photogrammetry only mode, so for those systems like the AL3, you can detach IMU and LiDAR and just fly photogrammetry, which gives you longer flight times and less risk. So that's been quite popular. And then there's lots of other improvements, like live measurements in the profile view, or requests from customers scanning ditches and power lines for power line tag. So as you fly, you can already analyze how that power line is shaped. Yeah, that was a quick rundown. I hope I was still in time. Almost. Thank you for listening. Our booth is over there in this hall. Come by and visit us. I will show you the software, some data projects. Joe UAV with the CW-30 is right next to us. If you have any questions, please see us at the booth. Thank you very much.